This massive tube is called the MRI scanner, and it is mostly used to produce detailed images of what's inside of the human body to help diagnose and treat a variety of conditions. To scan a body part such as the brain, it can often take up to an entire hour. But why are we talking about this? The MRI machine is an amazing product that was invented almost 50 years ago. And till date, it has been a great invention which has solved some serious medical problems such as identify brain tumors. But then it has its challenges. It is expensive, it is time consuming, and as a patient, if you're inside that tube, it is extremely claustrophobic. So, what I'm wondering, can advancements in machine learning and computer vision solve this issue? Can it make things any better? Well, it turns out it can. And I recently discovered one of the tools that has been doing something like this, which I want to tell you about. So let's cover three things. Number one, I'd like to just dive a little bit into what is an MRI and how does it work. Secondly, I'll tell you a little bit about this AI tool that I've discovered for how to make MRIs better. And then lastly, you as a product builder, you as an application developer, what can you do? How can you leverage this tool and probably build it big? So let's dive in. So what is an MRI? Well, MRI stands for magnetic resonance imaging. Now, it is a machine which uses magnets, it emits radio waves, and it uses a computer to essentially just draw out whatever it's seeing. But what does it see? So essentially, any tissues, organs in our body is what it kind of sketches out, right? Now, our bodies are filled with mostly water, 70% is water. Water has hydrogen atoms. Now, when a human body enters an MRI tube or an MRI scanner, there is magnet in this machine, which is essentially creating a magnetic field. The hydrogen atoms in our body align with that magnetic field. Then this machine essentially emits a radio wave, and these hydrogen atoms knock out of their alignment. At this point, of course, you can see that, okay, there's something which is getting awry from its original calibration. The radio wave is then stopped by the MRI machine, and now the hydrogen atoms are coming back into the calibration, but when they do, the hydrogen atoms actually emit another radio wave. And that is what is captured by the scanner, which ultimately gets connected to a computer and then produces an image, which is what you see from an MRI scanner. Different tissues like fats, muscles, organs, they send back slightly different signals. So the computer can distinguish between them and then create a clear, sharp image. This really helps doctors to see what's going on inside of our bodies without really making an incision, doing surgery, x-rays, all of that nasty stuff. So no cuts, well, that's great, right? So there are immense benefits of MRI, not to lie, saves you from like all the things which I just said, and like earlier detects a tumor, like an abnormality with the tissue, all of that stuff. But it is extremely unpleasant being inside this tube, that too when it takes an hour with that knocking thud noise. So where is the good news? So it turns out scientists have now found a way to reduce the time it takes to complete an entire MRI scan by a tenth. So from an hour-long brain scan, that could be done in like 5 to 6 minutes. Imagine how cool that would be, right? So Facebook AI Research, or now as they're called Meta Fundamental AI Research, partnered with NYU Langone Health, and they have developed a tool called fastMRI, recently updated to fastMRI Plus, that helps make these MRI scans faster by using artificial intelligence. But how does that really work and how does it really make it fast? So to answer that question, let's first understand how the MRI machine actually creates an image, right? So a normal MRI machine basically collects raw data, which is the frequency which is being emitted by all those hydrogen atom movement, the radio waves which was being emitted, as I was telling you about, right? And it plots that in what is called a K-space. So this is, imagine like a 2-dimensional or a 3-dimensional large space, and then you do a spatial frequency mapping, right? So this could look like a really large image, and each pixel is what you start collecting. That is kind of how it is, right? And when all these pixels are created, or when the entire K-space is filled out, that's when you get an image, which is what you look at, which is the MRI scan, right? Now, for a clear picture to be collected, it needs to collect a lot of data, right? So if you're interested, you should look at a complete photograph and then look at how many pixels it has, and like if you have to collect all those pixels, that's just going to take a lot of time. Same thing in a way, right? Now the computer then processes these data points and makes a detailed image, which is what gets used. But then if that is the process, then how is fast MRI working and how is that changing it? Because it doesn't quite change the MRI machine, right? Well, it turns out there is AI at work which is doing some magic. So this magic, essentially, less data is collected in an MRI. Like say if you collect 10 data points, only 3 are collected, and then AI fills the gap. AI will fill out the rest of the 7. But then how does it really do that? So basically what's going on here is imagine if you have to draw an image with a lot of trees, right? So the first method, which is the real MRI method, is like you take every tree and like draw it precisely. Then like there's tree, there's the trunk, and there's the stems and leaves and whatnot, right? And then you go tree by tree, right? So that is a long drawn process. It's precise and it takes hours, as we've spoken about. The fast MRI process, what it does is, because ultimately it's a tool it's a data set which is already trained on similar images. In this example of mine, let's just say it's trained on these forests and these trees. So what will happen is an MRI machine will draw out one tree, and then fast MRI, because it's seen other such trees, will essentially produce the rest of the image. So say you've got 3 data points, then the rest of the 7 are filled out by AI. So that is kind of how it's reducing the time, and that is really how it's in action. So this technique is super helpful because it speeds up this whole MRI scanning process, right? And it can also like just increase the number of patients that could use this machine. What was taking an hour now takes say 5 or 6 minutes, so you could use that remaining time like helping more people get scanned. So that's all amazing. But then I said that you could also leverage this data set and build something. So what does that look like? So let's discuss a few ideas now. So I see 3 areas where this could be super helpful. I'm sure there are many more, but then these are the ones which come to my mind, and please use your creativity and let me know what else you can think of. But anyhow, so the first one is kind of speed up the whole MRI workflow, as I was saying. Second would be, how do you help doctors diagnose diseases more easily, like helping them out? And then thirdly, how do you create some sort of an educational tool around this, right? So let's dive into each of these a little bit and see what do I really mean by that. So on the first one, essentially, you could build a software that integrates with the MRI machine to speed up the scanning times and take the output of a 15-20 minute long scan and then extrapolate the whole scan from it, right? So you could offer this as a service for an entire chain of hospitals or just a local lab which has an MRI machine as well, right? So just like kind of like a point solution deployment for this fast MRI plus data set, that could be an application by itself. Now, in terms of the second one, then you could build an AI-powered diagnostic assistant. So imagine now, of course, this fast MRI dataset has created images. Can you annotate this? Because now you have all this imagery, and of course, like the tool set has the annotations as well. So that could help radiologists quickly identify where there could be a tumor or an abnormality in the body and whatnot, right? So that also saves some time, and that is where we could make the whole medical process a lot more efficient. So that would be number two for me. And in terms of like the educational tool, I was saying like develop some educational tools for radiologists or those in residency or those like who are still training to become doctors, right? So the annotated data set could create a lot of like training modules for this is how an MRI looks, this is how an annotated MRI looks, what could be for different diaspora, what could be, say, any changes for different geographies, people from different communities. All of that's something which could be out there. Could be a simple app, could be a simple tool, and will help a lot of people, even if they're not doctors, just to kind of understand what to look for here, right? So I'll leave the link of the research paper and the GitHub repository for fastMRI Plus. Please do give it a look and see what you can build, because I'm really interested in seeing how are you going to build it big. Until next time.